Hello again, everybody. If you've just joined us, I did a little preview a moment ago. We are also joined, as promised, by our very special guest, Dr. And I'm going to give it another shot here. Aomawa. No, Aomawa. Aomawa Shields. And it shouldn't be hard to say because it flows just as your parents had hoped it would. Dr. Shields, Aomawa, welcome to the book club.
Thank you. I'm so excited to be here. Thanks for having me.
We're very glad to have you. And as you can see, we still have people showing up here in the book club. I'm going to remind everybody that right where you're watching this in the chat is where you will be able to submit your questions or comments about the book to Dr. Shields. And we welcome those. They're going to be reviewed before they hit my eyes by Amber Trujillo, the mistress of all things here in the member community. By the way, happy Halloween, everybody, and the same to you, Aomawa. I'm going to get it right. Can you do, you said in the book that you wished you could do the little chant that your parents came up with that for the readers of the book. I did ask you yesterday, are you still willing to share that with us?
I am still willing to, yes. And it's particularly helpful because I think in the book, I also give you my middle name, which is tricky to really know how to pronounce unless you hear the chant. So the first and middle name are in this chant that goes, Aomawa, Aomawa la la hie, Aomawa, Aomawa, and then it goes over and over again.
So. Aomawa. It's wonderful. It really does sound, I mean, I can definitely understand why people would regularly ask you, is that African? Is that, you know, fill in the blank? Is it a Native American?
Hawaiian, maybe, yes.
Yeah, a little bit of everything. It's wonderful. You are the living, breathing nexus of science and art, which is a theme that runs throughout this book. And as I told you when we first talked, it's that interweaving of art and science, and one other factor that I'll mention, because that was always something that I've tried to do across my 20 years of planetary radio, and have always been fascinated by. We always tried to welcome that intersection, that overlap in the Venn diagram of art and science, and they really have been two, I won't say overpowering, but very powerful motivators in your life, haven't they?
They sure have. Yes, I almost can't remember a time before having those two loves. So they've been with me for as long as I can remember, and in my mind, they were never in contradiction. That wasn't always how it seemed others viewed it, and yet the book really is this journey to finding that level of acceptance of all of the parts of myself, for myself rather than for anyone else.
I think the other theme that I really welcomed in the book were your regular, and we'll make reference, I think, to a couple of them, where you found parallels between the natural phenomena we find all over the solar system and the cosmos and the development of your own life, which I'm sure was fully intentional. I love that you find those metaphors for what has been happening across your entire pretty fascinating life.
Yes, thank you. I was particularly satisfied with how, as I was writing the book, a lot of those came to me. This idea of, you know, we use a lot of analogies in teaching astronomy as it is, and I start the book off with one of them. There are as many stars in the observable universe as there are dry grains of sand on all the beaches in the world. That analogy comes from Jeff Bennett and Seth Shostak's book, Life in the Universe. And when I first learned it was very tactile to me, because not everyone has gone out with a telescope and looked at the night sky, but almost everybody knows what sand is, and perhaps even has held sand in their hands and in their palms. And so being able to, like, you pick up one hand full of sand and to see all the individual grains, which of course we can't even in that one handful, and to know that that's only one tiny handful on a huge beach, and thinking about all the beaches that exist on this planet, And then we're getting in the ballpark of how many stars there are out there. So that, I feel like I was raised in astronomy with thinking about analogies, and that felt like a natural extension to then apply that to my own life. And as I was writing the book, a lot of them came to me, like realizing that I had been gone from astronomy for exactly 11 years. And then realizing that that was the same thing. Our solar cycle is 11 years long.
Right,
And
right.
it was like, yes, of course. Yes, that has to be the name of the chapter. So.
I am struck by the fact that it's not just stars as numerous as the grains of sand, but planets as numerous as the grains of sand, which is what much of your science has been about, learning about those planets out there and which ones someone or something might find a decent place to live, which is quite a challenge when they are many, in most cases, many, many light years away, right?
It's so true. And, we didn't know this over 25 years ago, that what we know now is that almost every star has a planet around it. And depending on who you ask, depending on which study you subscribe to, there's maybe 15 to 25% of those planets are in this particular region of space around a star, which we call the habitable zone or the Goldilocks zone, which I'm sure most people on right now are familiar with that term.
Yeah.
And if you're not, it's that in that region around a planet, around a star, where a planet with an Earth-like atmosphere could be warm enough for liquid water to flow on its surface. And so, yes, now we have not only this number of stars out there, but number of planets. And if only 15% or 10% even of those stars, of those planets, are habitable zone planets, we're still talking about, billions of potential habitable worlds out there.
I have, as I mentioned to you, pages and pages of notes. I actually condensed them down to a couple of pages of my own questions, and we're not even going to get through all of those. But we do want to get to as many, if not all, of those that are coming from other folks. And I'm going to start right up front this time with one from Jeremy Kokal. I says, I really enjoyed the audiobook. Your description of snow days in Massachusetts and so many elements of the book really made me feel, and feelings are also something you talk about in the book and the importance of them. He says, your emotions were joyful and I connected with it. Clearly, you are bringing a theatrical element to science instruction, messaging, and public translation of science, helping us feel something powerful for space exploration, the search for life on other planets, and the bigger picture of scientific pursuits. All of which is really lovely all by itself, Jeremy. But then he follows it with this question: is science best served with emotional engagement? What religion and spirituality and art do for many with feelings, should scientists embrace these more? I'll save my answer, but I bet I know what yours is too.
We are starting right out of the gate. I love it. Yeah. And thank you, Jeremy, for what you shared. That knowing that the book, that you took that from the book, and that it was felt that way about the book, it really makes an author, and me in particular, feel quite fulfilled in that way of like the job was done, because that's what I intended to do with the book. I think that science can only benefit from those of us who are dedicated to it, bringing how we feel about what we're studying into the mix, into our study and pursuit of science. And since we're starting right out of the gate, I'm going to start off right out of the gate talking about Rising Star Girls, which is the organization that I started, almost a decade ago now, that encourages middle school girls of color to explore and discover the universe using theater and writing and visual art. And underneath all of those words is the subtext is, we want these girls to feel. And we want them to know that how they think and feel about what they're studying is not only important, but critical to their study and practice of astronomy. And this is all, we've seen in the literature how important it is that these kinds of exercises help girls of this age feel more confident in both asking and answering questions in the classroom. And beyond that, as they continue in astronomy and the heavy math gets into the mix, we want them to understand that they have a personal connection to the universe because they've written a poem about that star or galaxy, or they've drawn a picture, or they've created their own artist's depiction of an extrasolar planetary environment in the same way that NASA trained artists do. And so that personal connection will hold them like an anchor to what they're studying and make it hopefully less likely that they will abandon astronomy just because it starts to get hard. So that idea of bringing what we feel into science, when I started out, I thought that my feelings and my practice of science were two separate things, and it was like penguins and polar bears, never the two shall meet. And I thought that, like, I never had a science teacher say, well, how do you feel about what you're studying right now? How do you feel about that problem set you're working on? It seemed very results oriented. And now I know truly how creative science is. It's such a creative endeavor. We have to be creative to ask the questions we're asking about the universe, and even more creative to think about ways to address those questions. So science is and creativity, they overlap, completely. And yet we still have a long way to go towards encouraging our students and our professors to be able to know that, how you feel about waking up in the morning and working on that project is important and matters, and maybe needs to be more important than the to-do list that you have that you created 2 weeks ago, and you woke up this morning with 3 hours of sleep. Perhaps that means that you're not going to try to do 25 things today, and then of course it can go on up to being able to share our emotions and feelings about the universe and the wonder and passion that those of us who love astronomy, right? Everyone here is on here because they love planets and, and astronomy and the universe. We can, the more we share that with others, the more excited and passionate and they feel that wonder. They get that. It's almost like it goes like an intravenous tube. I've noticed that when I talk to my students, if like an 80-minute lecture is going to be pretty boring if I'm going through it like this and this is what a star is and this is what the planets could have. But if I am engaged, if I am sharing, those stories of discovering the night sky for myself, they feel that, and that keeps them inspired, and more importantly, it keeps them awake. So.
I love to ask astronomers, scientists, what first got them excited? What first gave them that? We use the term all the time, and it's right from our boss, Bill Nye, the Science Guy, PB&J, the passion, beauty, and joy of space and science. I want to ask you the same question, but I know that you've had it for ages because I'm thinking of this little girl walking along, bumping into things because she's looking up at the sky the whole time.
Yes. It's as long as I can remember, it was like that was what I wanted to look at. That seemed the most interesting to me, was up. And yes, I had a few bumps on my head as a result. And, and it was also, I was thinking even more about this. And I talk about this at the beginning of the book. Like, there were a few things. There was my grandmother working at Miramar Air Force Base. I think it's now called Naval Station Miramar. But back then, that was where the original Top Gun movie was filmed. And even before Top Gun, we would go to these Blue Angels flight shows that they had on the weekends. And the Blue Angels was this incredible, I think they're still around, this aerial. Yeah, right.
They were in the area recently.
Right. They have like a legacy and a history, and, and the Blue Angels, this aerial flight team, and they do these death-defying acts in the sky, and come within, tens of yards of each other. And we would sit on the grass, and it was like, that was our football game. And I would look up and see, and that started that, kind of reinforced this idea of there's so much exciting that's going on up there. And then of course, seeing the movie Top Gun, that moment of Kelly McGillis's character walking down the aisle, that after the night where Tom Cruise and Anthony Edwards' characters both, think she's like whoever, some random chick, then they hit on her, and then they go back to their flight school day, and like she's the featured astrophysicist, and she like whips her head around and has those classic aviators, glasses. And I was just like, yeah, hell yeah, astrophysics. I'm on. And then the final thing was Space Camp, was seeing the movie Space Camp.
I'm glad
at
you
age
brought that
12.
up. Yeah.
Yeah. I mean, that was the solidified it for me when I saw that kids could get launched into space. This could happen. Like that made me really believe that it could happen. And one thing I don't really talk too much about until later is the Space Shuttle Challenger disaster, which happened, the same year of I believe, so Top Gun, I think it was within a few years of Top Gun, but it was 1986. And so I was 11 at that time. So that had happened before I saw the movie Space Camp. And, all of these things, knowing that even though it could be an incredibly dangerous enterprise, I remember at the time, I was not deterred from that endeavor, and then seeing Space Camp and that was so fresh in people's minds, still Challenger. And I would get asked, aren't you afraid of that happening? And I was like, nope, that would be, an honor. And I didn't fully understand, of course, my little 12-year-old brain of what that really could mean. But a lot of those early influences, they all contributed to this dream forming itself quite solidly in my mind.
Before I do anything else, because I meant to do it right after you mentioned Rising Star Girls, which I was going to make sure came up in the conversation. How do people learn more about Rising Star Girls? And then we'll provide that again at the end of our conversation.
Thank you.
Sure.
Yes. To learn more, and I see that it's already in the chat, please visit our website.
Great.
We have a website called risingstargirls.org. And we also have a tab on that website called Take Action. And that is whether you want to donate, that's wonderful and so generous, and your donation is tax deductible, or whether you'd like to get involved in another way. We are always looking for people, especially younger people who are even closer to these girls' ages than I am, which means they'll identify more with you than me, to share their story about how they got inspired by the universe and interested in the universe. And whether you're someone who identifies as female or male, being a role model for these girls is very important, and they would love it, and so would I. So we'd love to have you involved. And there's an email that you can send a note to us letting us know you'd like to be involved, either there's different ways you can be involved, and we can give more information about that at a later time.
I want to thank Amber for popping that into the chat, which I'm not keeping my eye on because I'm looking where she's feeding me stuff. But that's great. And
thanks,
we will just look in the chat, folks, but we will, hopefully I'll remember, or maybe Alma will remember to mention it again at the end of our conversation. Yes. I only wish, you'd have to have been a lot older, I'm afraid, but I wish that you had been teaching your Life in the Universe course at UC Irvine, my alma mater, back when I was there as an undergraduate, because I sure would have eaten it up, and probably would have brought you on the student radio station too, KUC.
I would have loved to.
Are you still teaching that regularly?
I am, yes. So usually I teach it at least once a year, and sometimes twice. So this fall is often a time when I teach it. I'm on sabbatical this fall, but we'll be teaching it in the spring. But one of my other colleagues, we've got two other fantastic exoplanet astronomers in our department, Paul Robertson and Steph Salem. And so one of them is teaching it right now. And that's a very popular class at UCI. It's our Gen Ed class. So many students in that class are not declared majors in science of any kind. Some of them are business or other humanities majors. And that's all fine. There's not really much in the way of prior knowledge that's expected.
So I want to go back earlier in your life, but before I do that, here's another one from one of our viewers out there, one of our members. Happens to be Mark Hilverda, who is one of my colleagues at the Society, but is also one of the most passionate members of the Society's book club. He starts this way: "What a wonderful book. I really appreciate Dr. Shields sharing so many personal aspects of journeying through the professional worlds of both art and science. This passage, among others, is beautiful." Here we go, quoting: "How someone acts, writes, draws. These are all informed by the unique individual, who that person is and where that person came from. The legacy of that person's development and evolution is like a fingerprint on a piece of art in the world." So not bad, but here's the question. I'm wondering if Dr. Shields has any advice for high school students who may be wondering what to pursue in college or university when they feel pulled toward both the visual arts and science. And I know you went more in the direction of the performing arts, but you've done visual arts as well. I was enchanted, actually, by your description of doing astrophotography with film
I
and being
know.
taught how to work with that stuff in the dark room.
I know that. Thank you. Yeah, and I'd love to get back to that. I have what I consider a huge, huge, huge telescope, not like something you'd put in an observatory, but a large, you see one in the background, that's my small one.
Oh, yeah. Uh-huh.
And then I've got a much larger one that's in parts in the garage that I am looking forward to putting together, because the irony is that those of us often who are professors in astronomy don't often get out with the telescope, and look at the stars, or at least that's not my experience. I don't see a lot of colleagues doing that, and I don't do that as much as I'd like to. But that's how I fell in love with the sky, was getting my hands on the equipment out there and in the cold night. So I digressed. Visual art,
Okay,
visual art and astronomy. Yes.
I know the feeling. I have small, medium, and large telescopes, and I don't go out and use them nearly often enough. But yes, please, your advice to the high school student out there who's torn the way you were.
Yeah. Well, the main message of the book is that rather than have this be a dialogue about either or, let's introduce both and, or yes and, into the conversation more in our communities. There are a lot of people in the world that I realize, and that's one of the motivations for writing this book, is I once thought, as I mentioned in the prologue, that I was this rare magical unicorn. And after the TED Talk in 2015, I started to get more and more emails from people saying, yes, me too. I also loved this and that. And whether it's astronomy and acting, or, architecture and violin, and, how do I put those two together? And I think what I want to say to that student who has those two interests and they're not sure what to do is, you don't actually have to do very much. I am a doer. I've always been a doer, and in this kind of next phase of my life, I'm working on doing less. And as you could see in the book, a lot of those miracles that happened in my life came from not pushing, not trying to figure it out, but staying open to the universe showing me how I was supposed to put those two together. And, the TV show I hosted, the Wired Science TV show, was one of those examples. I didn't go out for that show. I didn't even, someone threw that in my lap and said, hey, you might be interested in this. And all I did was send a headshot in, and they were like, we have to get you to producers today. Like, that was an example. And, there are others, Neil deGrasse Tyson, and coming into my sphere, and basically giving me that. And I kept seeing it from all sides, go back and get the PhD, whether it was, the NASA astronaut application, or Neil, or, other experiences of seeing that my job at Caltech, working for the Spitzer Space Telescope, was really self-limiting without the PhD. And it's like, but if I had been closed off to this idea of how I was supposed to have a career, how I was supposed to be making a living, I think I might have missed all those cues from the universe. So one thing I would suggest to that student who loves visual art and astronomy is devote some time each day to those things that you love. And it doesn't have to be a lot. It can be 10 minutes drawing or painting or whatever that visual art, that specific medium that you enjoy. Do that. 10 minutes going outside, looking at the sky and journaling, or if you have access to a telescope, using that, or going to a planetarium, making, we talk about, I think many of us have heard of like these artist dates, and that comes from Julia Cameron's work, The Artist's Way. This could be, astronomers dates, like that idea of a date with yourself, to make that a priority, to make time for those things that are the most important to you. It's often, I know for me as a parent, it can be easy to put everything else before those things that really bring me fulfillment, just for me. so many aspects of being a parent and, and a spouse are fulfilling. There are also things that are fulfilling just for me. And I need to, if I do those things first, I find that everything else flows. Honestly, everything else is easier to do. I feel better. I feel happier. I bring that joy to other people. They feel it. And if the student spends just, 20 minutes a day, 10 on visual art, 10 on astronomy, whatever that looks like, opening an astronomy book they have on the bookshelf and thumbing through it, or a magazine, I tell you, the universe will pick up on that, pick up on those little seeds that you're starting to nourish, with soil and with water, and the universe will add to that, and there'll be, there will be a path that will be made clear to follow.
May not be a linear path, though, right? I mean, you say life isn't linear, and I would say the life of the solar system, the life of the cosmos, are our little individual lives.
That's true. And I also want to put a plug in for the University of Colorado Boulder. I have a good friend who's a colleague of mine, Zach Berta Thompson, and he is a kindred spirit in many ways because he also is an astronomer and an artist and an incredible exoplanet astronomer. He's an observer, so we're different in that way. But he often starts off his talks with a drawing that he's done by hand of a transit, a transit of a planet, of a star by an exoplanet. And you see that's his own visual art contribution. And then he starts in with the science and the plots. And I attended a talk he gave once and was just transfixed because he did that. He incorporated the art into, the very technical discipline that he was sharing about. And he now has, I think it's his first astronomy and art fellow. Like there's an undergraduate working with him. Her name is Abby, and she's doing a series of visual arts, kind of graphic depictions of, she calls them, heroes in science, and they're focusing on women in science whose stories have not been told. And I was fortunate enough to be featured in one of these artist representations, and so and that was started by Zach. This sort of astronomy and art as a practice. And so CU Boulder, I'm not sure if they've made this an official thing, but that student may want, whether fictitious or real, may want to look to that school because they could be a pioneer in this respect.
Lots of good advice. Thanks for the question, Mark. I'm going to go to another one here before I pick up again. Let's see. Mexican. This is from Claudia Ornelas. Mexican girls don't get much information about topics of science and their social upbringing environment, especially low-income children. As a woman of color, what advice do you have for aspiring scientists like my daughter, especially those interested in astrophysics and climate science, when what they believe is, let me see if I can get this, when what they believe in, I think is a really high level dream? You've partially answered this, but maybe for children who are even younger, and particularly people of color.
Mm-hmm. Yes. So this is what we are addressing, of course, with Rising Star Girls. And we target girls, or those who identify as girls, ages about 10 to 15. That's what we consider middle school age. However, we have been known to take younger girls in, 8 and 9, and even some older girls. And so I think I would say right away, and thank you for sharing that. I relate, of course, as you might imagine, and we would love to have her participate in Rising Star Girls. Now, if she's even younger, like, 6, 7 or younger, as my daughter is, I'd say just having the parent that she has, who's asked this question, who's cognizant of this, of the inequities, she's already off to a great start because she has you. And because you are aware that it might be harder, that she might, struggle from not having as many role models as those children who are not from historically marginalized communities. Something that I've tried to do with my own daughter is, she's not yet old enough to participate in Rising Star Girls either, although I consider her my own Rising Star Girl, is get books that show women and girls who are doing wonderful, amazing things. There's a series of books I may, depending on time, pop into her room and grab it. But I think it's called like Girls, Brave Girls, or it's a pink book, and there's a couple of them now, and it's just page after page of stories of girls who have changed the world in some way. And these are girls who are, and some of them are like, 12 or younger, all the way up to 20s and 30s, but they're focusing on younger girls and ways in which they are following their dreams. These are not all scientists, but it's that inspiration. It hopefully makes my daughter realize that she can do that too. She can change the world, in small or large ways. And there's these lovely, I get books and little like cards that have affirmations that are, I use those myself, and they have them that are geared for young girls and young kids, and there's mindfulness practices for kids. But what's very important for me and for our daughter, for both my husband and I, is to encourage our daughter to love and approve of herself as early on as possible. Because that's the thing that we notice in middle school, is that girls start to get quiet at that age in particular. They start to become more concerned about their appearance and less concerned about how they think and feel about the world. And that lack of self-confidence starts to take root at that age. And so that's where we try to start as early as possible. And that's what we're trying to do personally, with letting her know that regardless of what she gets from the outside, regardless of what the outside is telling her in terms of messages, she can have that full feeling of approval and self-love on her own. And that might make what she encounters in the world easier to bear, if she's got a strong sense of self. Well, there's some initial thoughts that come to mind.
Somebody looking at your CV or a short biography might be surprised to hear that these were also challenges that you dealt with. I am the proud father of two brilliant daughters with strong voices, who both went more in the direction of art than science, but they're science literate, which I'm especially proud of. One of them actually did stuff at the La Jolla Playhouse, where you also did some things down this way toward UCSD. They're both UCSD grads. Go Tritons, and Anteaters. But I'm coming out of high school. You described yourself as a Renaissance woman, acting, astronomy, softball, orchestra, and you set your sights on MIT. And then went into that first year there, your freshman year. You called it your year that you compared to the late heavy bombardment.
Yes.
Which I guess, for the people out there who may not remember the late heavy bombardment, maybe you should say what that is. But also here you had just been a wonderkind, right? Up until that point. And you really started to find out, boy, this science stuff can be a challenge.
Yes, the late heavy bombardment is this period of time not long after our planet was formed, when it was pelted by, objects from the sky, asteroids falling as meteors and meteorites. And there was a lot going on. It was this volcanic environment, the Hadean era, and everything that hit the moon that we can see evidence of because of the moon's lack of atmosphere and tectonic activity happened here. But because we're a lot, much more active, geologically active as a planet, we don't see the same kind of evidence of that bombardment, but it happened. And so this idea of being pelted from above and all sides, and that's what I related to my experience at MIT. They talk about it as it's affectionately referred to as drinking from a fire hose. It's like there's so much all of a sudden, and everyone at MIT was, did well. I was going to say was the best at, and maybe that's not true, but everyone, we all came from places where we had been very successful in high school. And then we all show up and it's like the slate is wiped clean and we're starting again, and everyone is bringing that high level of achievement. And I felt like it was overwhelming. It was overwhelming. And I think I wrote about that first physics class I took, where I had the instructor say, if you go on that ski trip with your advisor, because we had this great freshman advisor who had a chateau somewhere in the mountains and was going to have us all up there drinking hot cocoa and skiing. And, and he's like, if you go on that trip, you're going to fail this exam. Because he knew I was teetering on the brink as it was. And I'm so grateful that I listened, and lived in the library that weekend. And, but yes, it was that experience of fighting so hard for the grades that I got. And then I had these incredible roommates that I lived with, both Black women, both had Jamaican roots, one directly from Jamaica, one Florida by way of Jamaica. And it seemed like everything came so easy to them. I mean, they literally had, and they're even more, I think, indomitable today. I mean, one is the head of her internal medicine unit at Emory, in Atlanta. Wow. And the other one is has her own company and stuff. And so, but even back then it was it seemed and this is, of course, it's all perspective. It seemed like they could do all sorts of things at the same time and then ace those exams. And for me, it was so important for me to focus, because if I was distracted by this or that, my academic grades would suffer, which is an interesting element that I want to bring into the conversation, because I think, again, both can be true. What I'm saying and what the book is saying is that you don't have to choose forever, that you can have both, or you can say even more than both. You can have all those things that are important to you in your life. At the same time, when I went back to grad school the second time around, it was very important for me to choose. And for that amount of time, for that 5 years that it took me to finish that PhD, because I knew what it was like to give something 100%. I knew what it was like to give my whole self to something, and I knew what I was capable of when I did that. If I had tried to do both, the PhD in astronomy and the MFA in acting at the same time, I know I would not have been effective at either. And so I did, and this also was, came from my writing teacher, Natalie Goldberg, who had her edge. Instead of astronomy and acting, for her, it was Zen and writing, and she had that thing of, when she was with Zen students, she felt like a writer. When she was with other writers, she felt like a Zen student. And she had to accept that was always going to be the case for her. And I have that too, where when I'm with other actors, when I, hang out with actors from my old acting days, I'm I feel like a scientist, and when I'm with my fellow faculty in a faculty meeting, I'm oh my God, I'm such an actor, it's, it's still there. And it's just acknowledging that's always going to be an edge, and continuing on, not being oh, because I don't ever feel completely at home in this world or that world means I shouldn't be here. That's the thing I'm adding. That's not the truth. It's just a story. The truth is, yes, I feel this way, but me adding, and this means that, that's the part that I can remove. So, but anyway, she had said at one point that it was really good for her to she decided that writing was her main practice, and she gave it 10 years. And she knew what it was like to go the full distance with something. And then eventually she realized she did want both, and now she has both. And she starts her writing workshops with, there's Zen and there's sitting meditation as part of those. And I go to those, and this is the same thing for me. Yes, I chose astronomy, did that, got the PhD, and then realized, I want the acting too. And that led to things like the TED Talk and, writing this book and sharing that story and giving the kind of talks that really inspire me when I attend those kinds of talks, where I bring my personal background into the professional, that there is no dividing line in the way that I've often seen it, that has made that both of them there's like a path that's been created where they're both in my life. So, but it can be very useful to choose and helpful to choose for a while, because you see, in my experience, you can see what you're really capable of.
I love those interludes, by the way, with your writing and Zen Mentor, where you went off to spend time with her. I also think of, God, there's so many questions coming to mind, some of which I have in my notes, some of which are not.
May I break in again and say one thing about
sure.
the question that from the parent of the young girl.
Yes.
I also want to say, buy her a science kit. Buy her a science kit, and buy her, if you, that idea that you have to choose one thing now, and I get hung up on this too. My daughter loves to draw, and she loves the art, and so we're going to enroll her in art classes. But then she also loves to tinker, and she just builds stuff, and she'll have stuff that she's building at any one time and out of random parts in our house, and so we're trying to encourage that too, and all that STEAM, putting the science, technology, engineering, math, and art, like just by introducing something into into her environment, and then you can see what she gravitates to. So even if there aren't any dedicated programs for her age range and her community, I find that like the parents can be a very benevolent influence in that regard of exposing her to things, and not that there's always has to be something that she's doing, but these little small, a book, a science kit, and seeing what she wants to do more of, and keeping your eyes open for programs that might exist in your community.
And maybe a set of encyclopedias, although that's been pushed aside, right? You and I both used to sit down with the World Book Encyclopedia and get totally distracted from whatever we had intended to look up. That had a big part, I think, in my development, as I think it must have in yours.
It definitely did. We were talking yesterday about how I think I'd like to get her a World Book Encyclopedia set. Even with the internet and how easy it is to look up things, having something in your hands and being able to look at the pictures and just think about what am I interested in now, and look something up, I think it makes a difference.
So as you talked about how you have brought your acting skills, and you do have that MFA, and you have acted professionally, which is the title of a book by my favorite UCI professor, Bob Cohen, A Tough Life, but you do bring so much of that to what you do. I only wish, and I think it's improved somewhat, that more scientists who get their, 10 minutes to make their presentation at whatever conference had more performance skills, because as you say in the book, making a presentation is a performance.
Yeah. Yes. Totally agree. This is one of the reasons why I started a course at UCI in our department that's called Communication Skills in Physics and Astronomy. And Great. It's now part of the required curriculum for the Astro track.
Lucky students.
Yeah. I mean, and then that's something that's not taught in most grad programs. Certainly the one that I was in, it was not taught. And yet one of the things you're doing as a grad student almost from day one is giving talks, first on other people's journal articles, and then eventually on your own research. And it is a skill. It's a performance when you give it. The learning how to perform is a skill. And I write about that too, that in my mind, I didn't quite understand that is a skill, just like playing the violin or the piano or learning how to play rugby. Like all of those things take dedication and practice, and our bodies are the instrument, and so I have my physics and astronomy students doing vocal warm-ups and improv exercises, which are really important because something always goes wrong every single talk, just like every single night on Broadway.
Showbiz.
And, you gotta know how to roll with that.
Let me get to another question, a question and a comment. This one from Robin Gerhardt. Wow, wait till you hear this one. I adored your book. I laughed and cried my way through it. I'm embarking on a career change, applying to study physics at university after a decade of religious work. Your book was deeply encouraging. In fact, I may quote you in my application. I assume you'll grant permission for that.
Yes, of course.
So my question, says Robin, what is your opinion on humanity becoming a multiplanetary species? Does your study of exoplanets inspire you to, I'm paraphrasing, to believe that this is possible, or make it seem less feasible? Interesting.
Yes. And congratulations. It's very exciting that applying and knowing where, feeling that, led and called in that way. I've been using this, I've been saying this a lot, and I think that's because it really rings true for me. Many people may recall the movie Contact, and you've had Andrew in here recently, and so I know
Yes.
that it's a wonderful movie from 1997 that stars Jodie Foster. It's an even better book by Carl Sagan and Ann Druyan.
I agree.
And I mean that in the movie, when she's asked about whether life exists elsewhere, what she says is, if it's just us, it would be an awful waste of space. And I feel that too. I mean, we started off this conversation talking about the sheer numbers involved, and numbers of planets out there, and habitable zone planets, and I feel very hopeful, and that there are many other species out there. Now, I know there was also a question about comparing my viewpoint to the viewpoint of another book that's come out just a couple of months ago, in terms of what kind of life that might be. And it's likely true that, because on our planet, microbial life has been around for a far larger percentage of Earth's history than so-called intelligent life. And so it's very likely that what we would find out there may not be what we would consider highly intelligent life. Although, what is intelligent life? I talk about this.
Still out.
I share a slide in the Life in the Universe class where I show all these realities, bad TV on the slide, and I'm like, questionable about whether our species is intelligent. Anyway, so and this idea too of do we classify intelligent life as having the desire to go out in space and explore. People who are, for example, Buddhist monks living in a monastery on top of a mountain may not find it necessary to leave and go out and explore and use technology in that way, and yet would we consider them any less intelligent? So that idea of what is intelligent life takes up quite a large unit in our class too. So I also want to share that this idea of how likely are we to answer this question, are we alone, and become a multiplanetary species within our lifetime? Though as a scientist, I can't say with certainty, next 30 years, next 50 years, I can hearken back to the 60s, the Apollo landings, and how we were given a mandate by our then president that we would land a human. Of course, it was stated then that it was a man on the moon by the end of the decade. And we did that. And our motivation was not entirely altruistic. There were certainly political motivations in there too, but it was done. And if you look at the pictures of mission control at that time, they're very homogeneous, both in terms of race and gender. And yet we were able to achieve that enterprise. What would happen if we now allowed everyone to be at the table in answering the question, are we alone, within the next 50 years? I think we're capable of answering that question. I think we're even more capable of answering that question even sooner if we allow every single person, every single type of person to be at the table. And if we expand our view about who gets to be part of this enterprise. Yes, of course, those of us who are trained in science would be at the outset more appropriate to take care of a lot of the technical aspects of that enterprise. But I'm telling you, when I look at the girls that participate in our Rising Star Girls program, and they do these artists' depictions of exoplanet environments, and they get to make choices about the kinds of planets that might be out there, how many stars the planets orbit, whether there's life on those planets. If not, why not? And we get to see that those environments, those arts pieces, look very similar to the NASA artists' depictions. So what would it be like to involve people who are not even formally trained in science to be part of this enterprise? So I think this idea of answering the question about whether we are alone or not, and becoming eventually a multiplanetary species, it's entirely up to us, even more so than it is about the technical limitations. And of course, there are distances that traversed in terms of the next star system. But I heard multiplanetary species. I didn't hear interstellar species.
True.
So I think that's much more likely to be about motivation and inclusion than it is about technical limitations and propulsion capabilities.
And all of our members who are watching out there know that the search for life is right at the core of what we are at the Planetary Society. I'm going to come back to, because I have so many questions I'm not going to get to. We must consider what your contributions to determining the habitability of worlds beyond our solar system, because they are absolutely fascinating. I am utterly fascinated, as I told you yesterday, by the field of simulation mathematical modeling, which you have done some really pioneering work with. Before I do that, though, Susan Stalker wants to know, do you have a favorite project or activity that combines science and art? And is there one you would recommend for us to do and share with the Planetary Society community? Big question.
I do, and I must say this one I did not create myself. It's part of the Rising Star Girls handbook, teaching and activity handbook, which includes activities that I and other members of the team created, and those that we've curated from other sources. And this one that came to mind comes from Kelsey Johnson's Dark Skies Bright Kids program, which is out of UVA, University of Virginia. And this is, what is it called? It's in the handbook somewhere, but if I can look it up, it's basically like constellation. The kids get to create their own constellations. So all you need is black construction paper and a hole punch. And then you encourage the participant to cut holes out of the paper in whatever configuration they want to. And they get to name that constellation. First, it's a good idea to talk about, and this is part of the thing, you talk about how constellations are really just patterns in the sky. Those stars have no distance relationship, and there's ways that you can show that, represent that. We did something like that in the classroom where we talked about how it's all about perspective. You see something face on and it looks like it's very close together. You turn it and you see that, they're very far apart. So first, understanding what constellations are and that they're completely malleable, because it's about cultures and what different cultures saw in the sky. Then reading examples from different cultures, not only Western constellations and cultures, although those are included too, but also Native American constellation books. And there's some wonderful Dot to Dot in the Night Sky is a great book series, and they incorporate constellations from different cultures, African cultures, Asian cultures. Then that sets the stage. Then the participants get to do the hole punch thing. Then they get to name their own constellation, and they get to write an origin myth around it. Their own, story. So that's a wonderful example of the art and the science coming together.
That's a terrific example. Let me go to one of many strikingly beautiful portions of the book, lines from the book, and because it'll take me in that direction that I told you I want to go to. Here's the quote. Could host star spectrum interacting with water ice on a planet's surface and gases in its atmosphere affect the planet's climate and potential to be habitable. In other words, if we took the time to look into what happened as their star's light hit the air and ground on these worlds, might there be many, many more potentially habitable planets out there than we think, or at least have thought, I will add. Is this kind of at the core of a lot of the contributions that you've made to the search for life?
It is. It is. And Amber, I'm seeing some questions about wanting all of, like I shared a lot then about that that exercise. If you go to the Rising Star Girls Teaching and Activity Handbook on the webpage, and if you would post that link, then people can go there, and all we need is a few little bits of information about how you use the handbook, how you intend to use it, and you can simply put research, and then you can download it for free. And it has a detailed instructions about that specific activity in the handbook.
Excellent. Okay.
Thank you.
Thank you. I'm sure Amber's on that.
She did.
Okay. So your work, and
My
you know,
work.
how do we learn more, like whether these worlds that in our best telescopes may not even be a pixel, how do we learn whether they're habitable?
So it's
And
really
through your work.
Yes. So my work starts once a planet has been found. In many cases, there's two sides to what I do. I love to turn knobs and explore potential planets that might exist that we haven't even discovered yet, and think
In
about
your models. Yeah.
and using my models. This is the way that I do this. Is I start with models that have been historically used to predict climate and weather patterns on the Earth. And what we can do, though, so these are the same models that have been used to predict and highlight climate change and then show what's going to happen into the 2100s if nothing is done. These models, then I can change the host star, I can change the atmospheric composition, I can change the shape of the orbit, and how reflective the ice is, and make sure that that reflectivity matches the type of light that comes from the host star. And I'll say more about that in a second. But this allows me to then predict climate and weather on other planets orbiting other stars. What we discovered, and this was back when I was a grad student, there was a suppositional paper that came out that postulated that because water ice loves to absorb longer, redder wavelength light and reflects shorter, bluer light, that a type of star called an M star. M stars are the most numerous types of stars in our galaxy. They're 70% of all stars. They're much cooler and smaller than our sun, which is a G star. And these stars, because they're so cool and small, they emit the vast majority of their light at longer wavelengths, infrared wavelengths. And this paper postulated that planets orbiting these stars that have ice on those planets, that ice would absorb a lot of that light from that star, because that light is coming at the planet in the infrared part of the spectrum where the ice likes to absorb. And therefore, these planets might be warmer on average than planets orbiting stars with more visible and near UV light, which are actually the hotter stars. So it's that kind of dichotomy of planets around cooler stars are warmer than planets around hotter stars. Now, you have to make sure that you're putting the planet at the distance from the star where it gets an equivalent amount of light as the planet around the hotter, brighter star. So if you've got the cooler star, a planet orbiting a cooler star has got to get much closer up to its star to get the same total amount of light as a planet orbiting a hotter, brighter star. But if all other things are equal and both planets are getting the same total light from their star, the planet orbiting the cooler star is going to be warmer because of this ice albedo effect. Albedo is a fancy word for reflectivity. So this paper didn't do any modeling. They just kind of had a very short scaling argument. And I was able to do modeling with that paper's author and beyond to show that this is a real phenomenon that can significantly impact our idea of habitability and long-term climate. And we were able to show that interaction between a host star's light and a planet's surface and its atmosphere, because remember, there's water vapor and carbon dioxide in an Earth atmosphere. And if we assume that similar constituents would be in other atmospheres and on other planets, those gases love to absorb infrared light as well. That's why they're called greenhouse gases. They absorb infrared light. So if you have the atmosphere absorbing and the surface ice absorbing, water ice, that means a lot of energy, a lot of heat coming into the planet's global system. And that raises the globally average surface temperature. And so we've been able to show, we've used this principle to look at actual observed planets orbiting stars that have been found, like planets orbiting TRAPPIST-1, planets orbiting Kepler-62. We've done some targeted case studies of observed planets. And the other thing that we do is think about, are there really exotic scenarios we could find planets in that we haven't found them in yet, but that could exist? And an example of that is my postdoc, Anna Lobo, has a recent paper out looking at something we call Terminator habitability. Arnold Schwarzenegger reference intended.
Right.
This idea that could you have a planet? Because if we go back to these planets orbiting cool stars that have to be much closer to their star, when you're that close to a star, gravitational tides could slow down the rotation rate so much that you've got one eternal day side facing the star and the other side eternally frozen in night. And in that case, the day side could be searing hot, way too hot for life. The night side could be frigid, way too cold for life. And we thought of the question, could you have habitability only along the dividing line between day and night? And is it possible to have a stable climate state there? And we were able to show that it is, and that it depends on how much water versus land is on a planet. And we did a whole study there. But that's the other thing I love to do, even more so than habitability assessments of observed planets, is kind of think about outside the box of what could exist out there that we haven't yet found, and how likely would that be as an environment to support life.
It occurs to me, there may be a pretty good metaphor there in that Terminator habitability for the mix of art and science, and the Terminator between the two of those, and all the life that can be found at that location. We are already a little bit past our 1 hour mark. Do you have another couple of minutes to stick around with us?
Let's
That's
do
great.
it. Let's go for another 10 if you're up for it.
I am definitely up for that.
Okay.
So I don't want anybody out there, and I bet in this crowd nobody is deluded to thinking that, oh yeah, mathematical modeling, I mean, I guess the AI takes care of all of that, right? You just twist the knobs. There's a lot of work, a lot of heavy duty mathematics, right? And then I assume you have a fair amount of time on some supercomputer at UCI or across the network. You talk about comparing, like a 2-dimensional simulation to a 3-dimensional simulation, and that has got to make things far more complicated.
It does, yes. And it's true, although people are looking at how we could streamline this modeling work that we do in terms of being able to do large, the era of big data is here. And so this idea of, could we simulate the potential habitability of hundreds of exoplanets instead of just one at a time? And that certainly has its advantages, and I would be in favor of that if we did not, as long as we didn't sacrifice the robustness of the science. And these models, the 3D models, solve all the Eulerian equations of motion. We have continuity and mass balance and all of that, and we make some simplifications. Like, for example, that the horizontal scale of motion is much larger than the vertical scale, which makes sense because we're assuming these are Earths in general, where the radius of the planet is much larger than the width of the atmosphere. We're not talking about big puffy atmospheres. And that allows us to take some terms out of those equations and simplify things, and for things to run more quickly. And we're also able to use, to allow things like, if those who are mathematically inclined, or remember your physics and atmospheres, things like the hydrostatic balance equation we get to use, and because we're kind of filtering out density waves that can change on time scales that are, much much shorter than the typical time scale of the 3D GCM, global climate model, which is like half an hour. So these are, we have to know the science and the math to be able to run these models. And we have to understand how the models work. And once we do, then we can really take full advantage of the power of 3D modeling and understand how 3D modeling gives us so much more compared to 2 or 1D. Now, I always tell my students, don't knock the 1D modeling, because it has its place too, and it's quite powerful in its own right. It allows you to get to first order an idea of what's going on in the climate system, and you can do that much more quickly, and do a large scale survey, just changing a few things. You write a little code to, for example, if you want to see the effect of and explore the effect of, say, eccentricity, how oval shaped an orbit is that a planet has. You write a little code that steps the eccentricity up in tenths or hundredths by hundredths, and then you can have your 1D model run through all the eccentricities from 0 to 0.9 and spit it out in less than a minute. Now, if you want to do that same model with a 3D, same simulation with a 3D model, it's going to take you, a couple days, maybe a week to equilibrate, because you've now, with the 3D model, you're not assuming the atmosphere has been collapsed down into a pancake. You now are allowing the full atmosphere to be present on a planet, and all of the radiative transfer calculations that are going to, occur as the model seeks its way to reaching thermal equilibrium, which means the temperature doesn't vary wildly over like 20 model years or so. And even with all that, a week to finish a simulation, that's assuming the ocean is like a slab ocean with not much heat transport or zero heat transport. If you want to have a full ocean, a full 4,000 meter ocean, you have to add, a few more weeks in there for a model simulation to finish. But you also get much more sophisticated climate output. You get so many climate variables, it makes your head spin, and you have to really focus in on, what am I really looking at? What is the most prevailing climate variable that I want to see, and really quantify its impact on X, Y, Z, whatever I'm exploring.
I am struck by, as you say that, learning to find your way among all these variables and focus on the most important ones. It seems to harken back to what you said about having multiple goals and priorities in one's life and learning to focus on those. It's really too much of a stretch?
No, I don't think so at all. This is that learning to focus, which we're trying to get our daughter to do.
She's 6, right?
6-year-old. My goodness, yes.
It's tough.
She's incredibly brilliant, and and her teachers or teacher is saying that it's hard for her to like finish something because she's distracted by this or that, and we it's we think that it's, rather than it being a medical issue or an ADHD thing, it's that she has such this imagination that everything seems so exciting to work on, and I understand that. And I've lived that in my own life. And so we try to tell her, one thing well, one thing at a time. First things first.
We could go on and on, because as I said, I have so many other questions. I want to make sure that we get out there again for the people who are not with us live, watching the chat, and already see the link to Rising Star Girls, because a lot of people are going to see this after the fact on our website at planetary.org and in the Planetary Society YouTube channel. Once again, how do people learn more about Rising Star Girls, or any other links that you want to add to the discussion? And while you do that, I'm going to grab something over here. Go ahead.
Yeah. So please go to risingstargirls.org and explore. We've got some wonderful pages you can look at to see our gallery. You can see some of those images I was talking about, the artist depictions, and these are our participants' artist depictions of exoplanet environments, as well as some their artists' concept of NASA remote sensing images. You can learn more about what it is we do, when we do it, how often we do it, because we also carry out educator webinars for educators all over the world. So we have a couple of times a year where you can attend a webinar hosted by one of our team members and learn how to carry out Rising Star Girls activities in your own communities.
Okay, last question. And boy, am I thankful for this one, because it's a great segue into the book that we're going to be considering over the next month here in the book club. It came from Craig Griffin. My question for Dr. Shields would be, having read Alone but Not Lonely last month, what are Dr. Shields' thoughts on the abundance or scarcity of ETIs, extraterrestrial intelligence, in the universe, in comparison with Dr. Friedman's viewpoint? Now, a little background for people who missed it. Last month, we talked with my former boss, our executive director emeritus, about Lou Friedman, who looks at the Drake equation and comes up with exactly one civilization in the galaxy, us, and there are other possible answers for that. Here is that book that you just finished, Craig, We Are Not Alone, by the terrific writer Mark Hartzman, who some of you may remember I talked to on Planetary Radio and also during a Planet Fest about his earlier book, The Book of Mars. It is really fun. It's going to be controversial for some of you because he goes through the history of little green men and flying saucers on Earth, in addition to lots of real science. It is just providing the history. It's not advocating for it necessarily, but I think it's going to make for a very interesting discussion next month. And so there's the book to get, which is published by Quirk, and I do recommend it. As I recommend Life on Other Planets, a memoir of finding my place in the universe, which is from Viking, I believe, within the Penguin Group. Okay. So what about Craig's question? Your thoughts about the abundance or scarcity of ETIs in the universe? We kind of touched on this.
Yes, we did. And that was the book I was referring to. I had seen that question earlier, I think. And though I haven't read Alone but Not Lonely, I'm now familiar with the kind of thesis, I suppose. And and I mean, I agree that the likelihood that the life we find one day is microbial is much greater than the likelihood that the life we find could stand up and wave to us or say something. Would I consider that any less of a monumental discovery, earth-shattering, if you will, discovery? No. Life of any kind, microbial or not, would be, it would be groundbreaking. It would change so much of how I know I view the world. And my hope is that others would have their viewpoints changed as well. And I think it's all, as I said before, it's all about perspective. I can choose to see that knowledge as with fear, and what might that mean? And of course, the movie Contact gives you examples of how many people view that realization that we're not alone in many different ways. I could also choose to view that discovery with a sense of comfort, that we're not alone. And that means that a lot of the things that I might find big problems or big issues in my life maybe diminish slightly with the awareness that I'm part of something so much greater than myself. And yet we are also precious, each one of us too, and knowing that when we look up at the sky, that there really is something looking back, or someone looking back. I think that could provide an incredible amount of both humility and comfort, if we so choose to see it.
And that makes a lovely finish for this conversation. Thank you so much, Aomawa. I hope that we will have another chance to talk. I would love to do this someday on a stage in front of people who are actually in the room with us. I think it would be great fun. But I'll look forward to any opportunity. And congratulations on the book. Best of continued success with all of this work you are doing with young people, and also to tell us about the habitability of all that myriad of worlds beyond our own and beyond our own solar system.
Thank you so much, Matt. I've really enjoyed being here and talking with you and everyone online today. Thank you. Thank you for reading my book and for contributing to this conversation. Much appreciated.
That is Dr. Aomawa Shields, Claire Booth-Luce, Associate Professor of Physics and Astronomy at the University of California, Irvine. Go Anteaters. Get one more in, where she leads the Shields Center for Exoplanet Climate and Interdisciplinary Education. She has written, I'll say it again, Life on Other Planets, a memoir of finding my place in the universe, published by Viking. She's also a classically trained actor and a 2015 TED Fellow. Thank you to all of you who've joined us live here. Again, if you missed any part of this, it will be available at planetary.org and in our YouTube channel before long, might be a day or two, but not too long. And I hope that you'll be with us as we go on to We Are Not Alone in this ongoing Planetary Society Book Club. Have a great rest of your day, everybody. And Aomawa, thank you once again.